This records. Okay, now we're recording. All right. Definite integrals of composite functions. We've been looking at antiderivatives and indefinite integrals of composites using U substitution. Now these integrals have bounds. They're definite integrals. I want to evaluate and find the area under the curve between 0 and 4 of 1 over root 2x plus 1 dx. So by fundamental theorem, I can evaluate this definite integral by doing capital F of b, this 4 here, minus capital F of a, this 0 here. We're going to plug in and evaluate the antiderivative with 4 and 0. So I probably need to first find the antiderivative. What is the U substitution? What's the inner function? 2x plus 1 dx. Or just 2x plus 1 dx comes later. So du would be 2 dx. The derivative of 2x plus 1 in terms of x is 2 dx. So 2x plus 1 is given as u. What's dx equal to? I have 2 dx. What would dx be equal to? Just dx. Du divided by 2 or just half du? Luke said take du divided by 2, or similarly, 1/2 du is dx. 1/2 du. That's a part of the story. We've gotten our entire expression written in terms of u. What do you think I have to do to these two bounds? Are they in terms of u? I haven't done anything to them yet. No. I want my entire expression in terms of u. These bounds are associated with x. They're not associated with u. So to put them in terms of u, we're going to substitute 0 and 4 into our u substitution as well. U of 0 would be 2 times 0 plus 1. I'm going to change the upper bound and lower bound to be in terms of u by substituting those values into our u substitution of u equals 2x plus 1. So when x is 0, u of 0 is equal to 2 times 0 plus 1. 1. My new lower bound is 1 when I change it to be in terms of u. Same thing with the 4. 2 times 4 plus 1. 8 plus 1, or 9. It's going to work a lot better if I also evaluate and substitute my a and b, upper and lower bounds, to also be in terms of u, just like I do with the rest of the expression. Does that make sense? So I've set everything up so far? Okay. The definite integral, not from 0 to 4, but from 1 to 9, of 1/2 over the square root of u du. And for 1 dx, I replaced with 1/2 du, as you can see here. And for root 2x plus 1, since 2x plus 1 was going to be given for u, that's just the square root.
And it's 1/2 because 1/2 du is equal to.
Yep. Remember I took the derivative of 2x plus 1, that's 2 dx,
Yeah.
right? But I just want dx. There's no extra 2 up here.
Mm-hmm.
If it was 2 dx, I'd be great.
Yeah.
It's just 1 dx. So I need to solve this for 1 dx by dividing each side by 2, or multiplying by 1/2. Dividing by the square root of u. That would be the same thing as u to what power? The square root is a 1/2 exponent, but since it's in the bottom, I can make it
Negative.
negative 1. Now we can evaluate this antiderivative by using power rule. The antiderivative of u to the negative 1/2 would be u to the positive 1/2. We're going to evaluate this between 1 and 9. But I first need to make sure I have the right constant out in front. We need to do anything to that constant. If I take the derivative of this, is it 1/2 u to the negative 1/2, like it's supposed to be?
Oh, we need it.
Say again? I don't need anything up front. I can go with just a 1, right?
Oh, yeah.
Because if I take the derivative of this, isn't it just the same 1/2 that I would have up here?
Yeah.
Check your by differentiation. Do you need an extra constant out in front? I bring down the 1/2. I have the 1/2 I need already. Let's plug in 1. Let's plug in 9. So it's the square root of 9 minus the square root of 1. So if I already changed my bounds to be in terms of u, by plugging them into 2x plus 1, all I need to do is plug in 1 to u to the 1/2. Plug in 9 to u to the 1/2. Subtract away. Root 9 is 3, root 1 is 1, so root 9 minus root 1, or 2. What are your thoughts there?
And you got the u to the 1/2 by doing the antiderivative?
Yep. So we got to bump up the exponent, right?
Yeah.
Derivatives you take away from the exponent. So antiderivatives you have to add to the exponent. You add
Yeah.
1 more. 1 more than negative 1/2 is positive 1/2, right? That's pretty much the name of the game, guys, using first fundamental theorem. Only difference is now we have upper and lower bounds, so we also have to change those to be in terms of u. What are your thoughts? Anybody online got anything that still is not quite